1.29, it says an electric motor is mounted in a 3-point support system. So this point A, B and C, the motor weighs 80 newtons. So there's a weight 80 newtons here. Before starting, the belts tension are 125 newton each. So there is T1 here and T2 here, and both of these are equals to 125 newtons before they start. When running the motor, it is delivering a torque of 2.7 newton meter. So this torque right here is 2.7 newton meter. What are the reactions that support A, B and C? So basically we have to find out the forces at A, B and C. So if you look at the forces that are present on the system, we have this T1 and T2, which is along the Z direction, and this weight 80 newton that is in the Y direction. So in the X direction there are no external forces. So from the supports also we will not be having any counter force coming on the system. So X direction forces we can neglect in this problem. So for the Z direction forces, on B we are going to have a force this way, on A we will have a force going this way here, and on C there will be a force going this way. So let's name them FBZ here, FAZ and FCZ there. Now for the Y direction, this bolt right here will be taking most of the load, and at this point it is just resting on this surface here. So the reaction forces will be only at point A and point B. So let's call this as BY and this as FAY. Now we can start doing the force and movement balance to figure out these forces. So now let's look at the forces and moments on the system. So first thing, we will try to find what is happening with the pulley. So we look at the moments on the pulley here, because that's the part which is transmitting the moment. So there's a moment here which is given as 2.7 newton meter. Now earlier the setup was that this T1 and T2, they were same. So now for doing the moment balance on this pulley, if they are same, there'll be net moment on this and this will move, right? So for that purpose, what we will do now is, we will say that this T1 and T2, they will be slightly adjusted so that the net moment on the system is 0. And the top one here becomes slightly lesser and the bottom one becomes slightly more. So if I do the moment balance on this, it becomes 2.7 newton meter, which is a clockwise movement, positive, plus T1 minus T dash, and at a distance of 50 millimeter, because this distance is given to be 50 millimeter here. This is also clockwise, minus T2 plus T dash at a distance of 50 mm. So at the beginning T1 and T2 were same, so this term will cancel out. So from this we can solve the value of T dash equals to 27 newtons. So when the motor is in motion, this top one right here from 125 will become 98 newtons, and this one right here, it will become 152 newtons. Now for the force balance on the system, force balance, we are not considering forces in the X direction, so we'll start with the Y forces. And this is your Y direction here. So the only force that we have is this 80 newton force, and the reaction forces FAY plus FBY minus 80 equals to 0. Similarly, in the Z direction, we have FAZ plus FBZ plus FCZ, and these two tensions coming there. Now these two tensions, there will be 152 coming from the bottom one and plus 98 from the top one equals to 0. And these two are, if you notice here, in the negative Z direction. So we can fix this to a negative sign. Now for the moment balance, we will take the moments about point A and we will use the R cross F method. So the points for which we will consider moments are B, C, and this weight right here, that is, and these points which are your T1 and T2. So for these points we will consider this as the point where the force is applied. So let's start writing the value of R and force F. So if you are going for point B, relative to point A, the point B is only sitting this 150 mm apart, so this becomes 150 I cap, and the force at B is FBY J cap plus FBZ K cap. For point C, from point A we are moving this 75 in the X direction and this 200 going downwards in the Y cap direction. So this can be written as 75 I cap minus 200 J cap for the position vector, and for the force we have only FCZ K cap. Now coming to the point where the weight is applied, so let's call that point O here. So point O. Now point O is somewhere at the center here. So in terms of X, we will be moving only 75 millimeters. In terms of Y, we will be moving half the distance here, so minus 100 J cap. And in terms of K, the center along the Z direction is sitting at a distance of 100 mm here, so plus 100 K cap. And the force direction is in the J cap direction, so 80 minus J cap. Now for force T1 here, because looking at this point, your T1 will be applied here, and this distance from here to here will be 3 times 75 respect to A, so 225 I cap there. In terms of Y, we are looking at this gap right here, which is minus 50 J cap. And in terms of K cap, again we are looking at this distance, so 100 times K cap. The value of T1 now has become 98 newtons, so this is 98, and it's going in the negative K cap direction, so this is the force value. Similarly for T2, we will have position vector I cap is going to be same. Now in J cap, this T2 is further down by 100, so minus 150 in J cap there, and K cap is same location, so it remains the same. And the force value for T2, which is the lower one here, is now minus 152 K cap. So we are going to do cross product of all of these. So this, cross here, cross here, cross here, and cross here. And in addition to this, there is that 2.7 Newton meter. So basically, if you follow Newton millimeter unit, because all of the other cases here are Newton millimeter, so this is a clockwise Newton millimeter moment. So this has to be in the minus K cap direction. So minus goes there, minus K cap equals to 0. So the moment coming from the point B in this case will be minus 150 FBZ J cap and plus 150 FBY K cap. So this is coming from point B. Similarly from point C, we will get minus 200 FCZ I cap minus 75 FCZ J cap. From point O, we are going to get 8000 I cap minus 6000 K cap. Now the T1 here will give us 4900 I cap plus 22,050 J cap, and the last one, which is your T2, that will give us 22,800 I cap plus 34,200 J cap, and this 2,700 Newton millimeter is in K cap equals to 0. So now we can highlight all the I cap terms here. So this one is one I cap, an I cap here, I cap here, I cap there, and we can highlight all the J caps. So this is your J cap here, J cap here, and J cap there, and the last one here is your K cap, which is K cap, K cap, and K cap. So based on these, we can write down 3 equations by doing total moment sum equals to 0. So your first equation for I cap can be written as minus 200 FCZ, then plus 8000 plus 4900 plus 22,800 equals to 0. So from this we can directly calculate the value of FCZ, 178.5 newtons. Now from the J cap equation, we have minus 150 FBZ minus 75 FCZ plus 22,050 plus 34,200 equals to 0, and we have already calculated this. So the value of FBZ that we get is 285.75 newtons. Now from the K cap equation, we get 150 FBY minus 6000 minus 2700 equals to 0. So this gives us the value of FBY equals to 58 newtons. So now we got the value of three components, both Y and Z at B and Z component at C. So now let's look at our forces here. So we have got this value, we have got this value, and we have got this value here. So from these two equations we can get the value of FAY from here and FAZ from here. After substituting, these values are 22 newtons as FAY and minus 214.25 Newton as FAZ. So these are the 5 values of forces that we have got. At point A we have this reaction right here and this one right here. At B these two, and at point C this one right here.